Okay, here we go. So I decided that I was going to show you how to do these things in Excel in a shocking turn of events, I know, rather than subjecting you to my messy handwriting on my iPad, because what we'll do is simultaneously build a timeline and do the computations. And so the name of the game in this chapter is we want to bring multiple payments either into the future or into the present, right? So if you look at the table of contents over here, we've got the future value of multiple payment streams, the future value of an annuity stream. An annuity is a series of the same payments annually, right? The present value of an annuity, perpetuity, which is, it's not really a thing anymore. It just makes a computation easily when you had to do that by hand. We're going to sort of stop the first lecture here. First thing we want to look at is computing the future value of multiple cash flows. So the setup they give you is you're going to put away $2,000 today, and over the next 3 years, you're able to put away $3,000 at the end of the first year, $4,000 at the end of the second year, and $5,000 at the end of the third year. How much will you have saved by the end of the third year if you are investing at 5% a year? Okay, so you'll see that they have a timeline here just drawn with an arrow. And so what we can do in Excel is we can make the timeline. Right, so we have time 0. So that's sort of today. And then T1, T2, and T3. And of course, being lazy, not that it really makes that much of a difference. There we go. Okay. So there's our timeline. In fact, we can sort of make this look kind of like a timeline by giving it an outside border and giving it some color. Put those in the middle. Right, and there it is. Okay, now, right, at time 0 today, we had a cash flow of 2,000. And in T1 it was 3,000. At the end of the second year it was 4,000. At the end of the the third year it was 5,000. Okay, so what we want to do is move all of these cash flows up to the end of year 3. So at year 3, right, we have this $5,000, and then we're growing this, right, so we're going to take the future value at 5% for 1 year. We don't have a payment. And the present value is this. Now remember, if we want it to be a positive number, we have to take the negative of it. And there it is, 4,200. Okay, so just like in the book, that's how you do it in Excel. You take the future value of each of these. So let's go ahead and do that again for the next one, which has to grow for 2 years. Payment was 0. Present value was a negative of this. Close paren, and that's 3307.50, just like it shows you in the book. And then finally, we can do the future value of the first cash flow today. So the rate, 3 periods, payment was 0, present value was negative, and there it is, 2315, just like here. If we sum all these up, we get to what it shows in the book, which is 14,822.75, precisely the same. Okay, so as you grow each of these, so remember the setup was, right, you're saving all these amounts every year. How much are you going to have in the bank at the end of this if you're growing your money at 5% a year? And I should note that the sum of just these deposits is 14,000, right? And here it's 14,822. So this shows you how money grows. Okay. Okay, so the next section in the book talks about calculating the future value of an annuity stream. And an annuity stream, for our purposes here, is the same payments every year, or you can have annuities with the same payments every month. The idea is, though, that that annuity in this case is the same payment at a regular interval, and so rather than going through this whole equivalent analysis where you bring each cash flow up to the future, which isn't too bad if it's 5 years, but when you talk about many years of annuity payments, it can become cumbersome. And the thing is that the math, because your cash flow is going to be the same every year, the math allows for you to simplify the calculations. And this takes you through, how those calculations are derived. But guess what? We're not going to do that because we're going to use Excel. All right, so here we have our application. We have a college fund where the parents are putting $1,500 into a college fund every year. On his birthday, with the first deposit 1 year from his birth, the college fund has a guaranteed annual growth or interest rate of 7%. And on his 18th birthday, he can pay the last $1,500 in. How much will be in the college fund for Eric on his 18th birthday? Okay, so we're going to set this up, right, just like we did in the last chapter. We're gonna make a nice, neat little table for ourselves with a border, and then we're just going to take our information. Okay, so the rate was 7%, and the number of periods was 18 years. But now, right, now we are going to use this payment argument. Okay, we want to know what is the future value of this series of payments. Okay, so the payments were $1,500. We're going to take them as a negative because those are cash flows that are moving away from the parents. Now the present value is 0, right? We're going to leave the type as 0, I believe, and we're going to solve for the future value. Okay, so here's our rate, 18 years. The payment is a negative 15,000. Present value is 0, type is 0, and there it is. 50,998. And sure enough, right, you can do it using an equation. You can do it with a financial calculator. You can do it with a spreadsheet. They all give you the same number. Right, so that's how you calculate the future value of an annuity. You use the payment argument, and you enter the payments as a negative number. Right, we want to know the present value of an annuity. No big deal, right? We can just, apply this same kind of analysis to a present value. But the question becomes challenging in the application, because that's when the timelines come into play, right? So, calculating the present value of 5 years of an annuity, no big deal. You just pull each of these down to the present by dividing them by 1 over 1 plus r to the n, right? And then, the chapter takes you through the math to explain, how to get to that 1 over 1 plus r to the n. All right, so Ben and Donna decide that upon retirement, they will need to withdraw $50,000 annually at the end of each year for the next 30 years, right? So they're going to retire at 65, and they plan on living until 95, and they expect that they're going to need $50,000 a year in their retirement. And right now they're not retired yet. What we got to figure out though, right? So think about this, right? They're going to want to have enough for 50,000 times 30. Well, 50 times 30 is 1.5 million, right? I should say 50,000 times 30. It's 1.5 million. That's a lot of money, right? But do they have to have $1.5 million sitting in the bank right on the day they retire? No, because the money that they have in the bank is going to be growing. It's going to be growing at 4% a year over these 30 years, right? So 1.5 million is the sort of nominal amount at 0 interest, right? But if the investment of that, that retirement nest egg is growing at 4% a year, they're going to need something less than that, right? So we want to do the same kind of thing. Let's just copy this little box here. But take out the future value, actually take out everything. Okay. And what we're going to do, what we need to do is solve for the present value with the payment of 50,000, 30 years at 4%. Right, and we want to solve for the present value. Our type is 0. Okay. So we just simply, figure this out. Our rate is 4%. Our periods are 30, I'm sorry. Our payment is 50,000. We can take the negative. And we can just close the parentheses. You don't actually have to put in the zeros if you don't want to. When an argument in Excel is inside those square brackets, that means it's an optional argument. Okay, it's 864,000. Right, so 30 years worth of $50,000 payments only adds up to 864,000 if you are growing at 4% a year. So that's kind of cool. That's basically about half of what the actual nominal value would be of 4%. Okay, and then this book or this example doesn't actually have you solve this out, but let's say, imagine you're 30 now and want to have $865,000. Oops. By the time you're 65, based on the analysis above. Okay, so you have 35 years to save. How much do you need to put away every year? At, we'll say 5% interest. Okay, so this is retirement planning. This is precisely retirement planning. So you would, again, let's just copy our little box here, copy it. But now, right, our rate, let's empty everything out. Now our rate is 5%. We have 35 years. The payment is what we're going to solve for. The present value is unknown, is irrelevant, and the future value now is 864, no, we'll say 865, right? So now we want to solve for the payment. So at 5%, number of periods 35, present value we don't know, future value is 865. So how much do we need to put away? $9,577 a year for retirement. If you do that every year between the time that you're 30 and the time that you're 65, then you'll have $865,000 in the bank at that point, which if you invest it at 4%, you can live on at $50,000 a year for 30 years. Retirement planning, right there. Personal financial planning. Okay, so this last section I'm not going to do much over in Excel. I just want to demonstrate something really quick. It makes a difference whether the annuities are paid at the beginning or the end of the time period. It makes a difference in terms of the calculation, and where they show up is in this question of type over here in Excel. Right, so I'm going to go ahead and just complete this present value calculation. I'll show you what pops up when the type shows up, okay? We got rate. Okay, so type, you notice that Excel prompts you. Type 0 means that the payment is occurring at the end of the period, and type 1 means it's occurring at the beginning of the period. Now, that's why they were so deliberate about noting that when the family was saving on their kids' birthdays, that it was, at the end of the period. It was type 0. Some annuities are due at the beginning of the period, or some annuity payments occur at the beginning of the period. They call that an annuity due. This is not a phrase that I've ever heard batted around in normal financial life. It's here in your textbook, and that's what it means. So that is, annuity due means that it is a payment that is occurring at the beginning of the period. Ordinary annuities are paid at the end of the period. That's why the type option in Excel defaults to 0. Because most annuities, if you think about like a car payment or a mortgage payment, those are annuity payments to get you to a present value of, whatever the cost was of the car or the home, right? And we'll get to those in the examples. So that is the annuity due concept.